Let us consider a compound statement S. And this compound statement consists of substatements P, Q, R, and so on. What we can do with this particular compound statement is we can make a table, which will be referred to as the truth table. So what happens in a truth table? It consists of rows and columns. Now these tables usually have rows and columns. So generally in the left hand side of the column, we will have the truth values of the substatements P, Q, R, and on the right hand side we have the truth values of the compound statement. So truth values means generally it could be true or it could be false, or it could be a combination. We'll talk about that in a moment. And then we check for the corresponding truth value of the compound statement, which could be either true or false. So we'll begin by considering a single statement or a simple statement. So let's say we have a single statement given by P. Then this is going to have two truth values. So one of the truth value is T, which is true, and the other truth value is false. Then we can have two statements. Let's say we have two statements P and Q. So their truth values can be a combination, so where both P and Q can be true, or the scenario where P is true but Q is false, and we can have P is false and Q is true, or both P and Q are false. Then let's consider the scenario of three statements. So let's say P, Q, R. So they can have a combination of 8 values. One could be all three of them are true statements, or it could be P and Q are true but R is false, or we could have a case when P and R are true but Q is false. Then we can have T is a true statement but Q and R are false statement. Then we can have P as a false statement where Q and R are true statements. Similarly, we can have F, T, F, 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 T, and finally all the PQ statements are false. So we begin by constructing the truth table for this compound statement P and Q, which is a conjunction. So we have P, Q, and the compound statement P and Q. So we have 3 columns. We begin by considering different values of P and Q. So the first combination can be when both P and Q have truth value T. That in that case, P and Q, so that will give us a truth value T. Then we have P having the truth value T with Q having truth value false. Then in that case, the conjunction between true and false is a false statement. Then we have P is false and Q is true. That in that case, P and Q will be false. And when both of them are false, then the truth value of P and Q is also false. Let's consider P or Q. So we have P, Q, and the compound statement P or Q. Similarly, we'll be considering the 4 cases for P and Q. So it could be both true, one of them is true, or both of them are false. So now we'll try to construct the truth values for P or Q. So when both of them are true, then T or T is going to give us T. True or false, so this is going to give us true. False or true, this is going to give us true. And when both of them are false, this is going to give us false. All you have to remember is that when it is a conjunction, then when both of them are true, only then we'll get a true value, and in all the 3 cases we have false values. Whereas in the case of a disjunction P or Q, when at least one of them is true. When at least one of them is true, then we have a true value. And when both of them are false, we have false value. So using these two particular ideas, now we can construct some other truth values. So let's do that. So we have to construct a truth table for P and not P. Fine. So we have, this is going to be a single statement. So we'll only consider P. And since this is a single statement, it can have only two possibilities. So P could be either true or it could be false. Then we consider the negation of P. So if it is true, then it's going to be false. If it is false, the negation is going to be true. Then we'll have to take the conjunction between both of the two values. So we have P and not P. All you have to remember, when both of them are true, then it is true, and all other cases it's going to be false. So this is true and false. So this is going to give us a false statement. Fine. What about P or not P? Right. That in that case, P or not P. So we have true or false. We know that. So whenever we have a disjunction, so the truth value of a disjunction is true if only one of them is true. So here we have at least one of them is true. So this is going to be true value, F or T. So this is also going to be a true value. So here in this particular problem, we have a disjunction. We have the negation of a disjunction P or Q. So we have to construct a truth table for this. So we begin by considering P and Q, which is going to have four possibilities: true, 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 false, false, true, false, false. First, we'll try constructing the truth table for the disjunction between P and Q. So that is P or Q. And we know that this value, it's true when at least one of them is true. So that means for the first three scenarios, it will be true because at least one of them is true. And when both of them are false, this is false. Now we have to take the negation of this statement. So that means negation of P or Q. That will be simply flipping the values. So we have false, 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 true. However, we also know that this can be rewritten as negation P and negation Q. So let's verify this using the same truth table. So we already have truth table for P. So the truth table for not P, negation of P, so that will become false, true will become false, and false will become true. So we have false, false, true, true. Similarly, we have the truth values for negation of Q. So that will be true, false, true, false. So we'll have false, true, false, true. Now what we have to do, we have to take the conjunction between not P and not Q. So this is only true when both of them are true. So that means only in this scenario we'll have a true value. All other case will give us false value. And we immediately see that this truth value is exactly equals to this truth value. They matches. So that means this. So these two statements are equivalent statements. So we have the conjunction P and Q, and we have to negate it and construct a truth table for this statement. So we have P, Q. So P and Q. So this is only going to be true when both of them are true, else it will be false. Then we negate the statement. So the negation will be flipping the values. So we have false, true, true, true. So this is the truth table for negation of P and Q. However, we know that this particular statement can be also expressed as not P or not Q. Fine. So let's try that as well. So we have not P. So that value will be, and not Q will be flipping the values of Q. So this will be, now we have to take the disjunction between not P and not Q. So not P or not Q. So we know that when at least one of them is true, it's going to be true. So that means for these three cases, it's going to be true. And when both of them are false, it's going to be false. So we see that since this column matches with this column, so we can say that these two are equivalent statements. So we need to construct a truth table for not P or Q. So we begin with P and Q. So the truth values could be, then we have negation of P, so that will be false, false, true, true. And negation of P or Q, so consider column 2 and column 3. So true or false, so this is going to be true. Both of them are false, it's going to be false. One of them is true, it's going to be true. Let's move on to the next problem. So in this problem, we have to construct a truth table of the negation of P or not Q. So we have P, we have Q. So let's take the truth table of not Q. So not Q will be flipping the truth values of Q. So this will be false, true, false, true. And then in the next step, we take the disjunction between P and not Q. So that means P or not Q. So that means when one of them is true, it's going to be true. So this is true. This is, both of them are false. So this is false. One of them is true. This is going to be true. And then we have to take the negation of the statement. So that was simply flipping the value. So we have false, false, true, false. However, we know that this statement is equivalent to not P and Q. Usually it is this not of not Q. So this is simply not P and Q. Now we will consider the truth values of not P. So P is true, true, false, false. So not P will be false, false, true, true. So now we have to take the conjunction between not P and Q. So we'll have to consider this and this. Since this is a conjunction, so it's going to be true only when both of them are true. So we have true, false, so it's going to be false. Then we have false, false, it's false. So we have true, true. That's the only case when it's going to be true. We have false, true, so this is going to be false. So here we can see that these two columns matches, so these statements are equivalent. Let's move on to the next problem. So we have to construct a truth value for not P and not Q. So we have P and Q truth values. So let's find the truth values of not P and not Q. So this will be simply flipping the values of P and Q. So we have false, false, true, true, and not Q will be false, true, false, true. And then we finally take the conjunction between not P and not Q. So this will be true only when both of them are true, which is in the fourth case, else everything else will be false. So this is how we can construct a truth table. Let's move on to the next problem. So in the next problem, we have to find not P or not Q. So in the previous problem, we had not P and not Q. So we pick up the same truth table from the previous problem. All we have to do now is find the disjunction between not P, not Q. So this is only going to be true when either one of them is true. So both of them are false. So this is false. And then the rest of them will be true. While we are at this, let's check out what will be the negation of this entire truth, entire statement. So all we have to do is negate the truth value of this final column. So negation of not P or not Q. So this will be, so we have false, so this will become true and rest will be false. However, this is the same as saying we have negation of negation P, the disjunction will become a conjunction, and we have negation of negation Q. Or this is simply, we know the negation of a negation is the statement P. So we have P and Q. So let's verify if this is true or not. So we have to find P and Q. So we know that P and Q, that's only true when both of them are true, else it is false. So we have true. So in the rest of the case, we have false. So we see that these two columns are exactly the same. So this is the equivalent way of saying the same thing. So we have to construct the truth table for P and Q, and this is a conjunction with not P. So let's begin by finding the conjunction between P and Q. So we have true, false, false, false. Then we consider the truth values for not P. This is not P, so this will be false, false, true, true. And then finally we have P and Q and not P. So we'll have to consider column number 3 and column number 4 and find the conjunction between them. So this is, we have true and false, so this is going to be false. False and false is always false. False true is false, and false true is false. So this is always giving us a false value. So in this problem, we have 3 substatements P, Q, and R. So we have to construct a truth table for this compound statement, the conjunction between P and Q, and this is in disjunction with R. So let's start by listing out all the possible values of P, Q, and R. So since we have 3 statements, so there will be 8 possibilities. So this is generally counted as, so since we could have only 2 possibilities, it could be either true or false. So it will be 2 raised to the power of how many substatements are there. So since there are 3 substatements, so this is going to give us the number of possibilities. So there will be 8 possible truth values. So we can quickly see that. So this will be, so here I've listed all the 8 possibilities. So let's begin with P and Q. So we have T and T, so this will be true. So when both of them are true, only then it's going to be true for a conjunction. Rest it will be false. So this is false, 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 false. Now we'll take this conjunction and then we OR it with R. So in that case, when at least one of them is true, then it is going to give us a truth value T. So this is T, T. So we have at least one truth value here in this combination. So this will be 3. Both of them are false. So this is false, true, false, true, false. So this is the truth table.